let's now look at the preparation of insoluble carbonates. Insoluble carbonates are prepared by precipitation method. Precipitation method involves the addition of a solution containing a carbonate radical to another different solution. For example, let's look at the preparation of lead carbonate. Let's take down what we have mentioned. Insoluble carbonates are prepared by precipitation. They are prepared by precipitation method. Let's take an example of lead carbonate. Let's take an example of lead carbonate. How is lead carbonate prepared using precipitation method? Lead carbonate can be prepared using a precipitation method by adding a solution of sodium carbonate to a solution of lead nitrate. If we have a solution of sodium carbonate, and then we add it to a solution of lead nitrate, what we shall get at the end of the day, the product that we shall get at the end of the day is a precipitate. And this precipitate is lead carbonate. And in addition, sodium nitrate will also be produced. In addition, we shall have 2 moles of sodium nitrate produced. So lead carbonate produced in this reaction is insoluble. So this is a method that we can use to prepare insoluble carbonates, precipitation method. Let's look at properties of carbonates. Let's look at properties of carbonates. We look at properties of carbonates. What are the properties of carbonates? Among the properties of carbonates, we need to look at their physical appearance. Physically, when you look at carbonates, how do they look like? Physical appearance. All carbonates, they exist as very fine powders. Naturally, all carbonates, they appear physically as very fine powders. Physically, all carbonates exist as very fine. They exist as very fine powders. Then what about their solubility? Solubility is also a feature that describes the physical properties of carbonates. Yeah, actually all carbonates are insoluble in water except the carbonates of potassium, the carbonates of sodium, and the carbonates of ammonium. Yeah, this is property number 2, solubility. Yeah, all carbonates are soluble, all carbonates are insoluble, all carbonates are insoluble, all carbonates are insoluble, except those of potassium carbonate, except those of sodium carbonate, and except those of ammonium carbonate. Let's look at the effect of heat on carbonates. Let's look at the effect of heat. Effect of heat of on carbonates. Something very interesting and something so important for us to discover how heat affects carbonates. All carbonates, they are affected by heat except the carbonates of sodium, except the carbonates of potassium, and except the carbonates of ammonium. The rest are affected by heat to give 2 major products. And these 2 major products include the oxide of the metal and carbon dioxide gas. Let's note this down. All carbonates are affected by heat. Are affected by heat to give 2 major products. i.e. an oxide of the metal, and carbon dioxide gas, There is something important we need to note. As we are insisting that all carbonates are affected by heat to give 2 major products, that is an oxide of the metal, carbon dioxide. On the other hand, we have got some carbonates that are not affected by heat. And the carbonates that are not affected by heat are the carbonates of potassium, carbonates of sodium, and carbonates of ammonium. We need to note this down. Note carbonates of sodium, that is sodium carbonate, and carbonates of potassium carbonate and ammonium carbonate and ammonium carbonate they are not affected by heat. The three carbonates are not affected by heat. They are not affected by heat. Let's look at the equation of the reactions when the rest of carbonates of higher metals when they are affected by heat. Yeah, for example, how is zinc carbonate affected by heat? Zinc carbonate, which is a white powder, it is affected by heat to give zinc 2 oxide and carbon dioxide gas. Zinc 2 oxide is yellow when hot. It is yellow when hot, and it is white when cold. Let's look at lead 2 carbonate, how it is affected by heat. Lead 2 carbonate in a solid state, when it is affected by heat, we get lead 2 oxide and carbon dioxide gas. Lead 2 carbonate, it is a white powder. Lead 2 carbonate is a white powder, and lead 2 oxide is orange when hot. It is orange when hot, and it is yellow when cold, and it is yellow when cold. Let's look at the effect of heat on copper carbonate. Yeah, copper carbonate, it is green in color. Actually, it is a green powder, and when it is affected by heat, we get copper 2 oxide, and copper 2 oxide is black in color, and in addition we get carbon dioxide gas. Carbon dioxide gas is also produced. Let's look at the reaction of carbonates with dilute acids. Let's look at the reaction of carbonate compounds with dilute acids. When a dilute acid reacts with a carbonate compound, we expect to get 3 major products. 1, we expect to get the salt of the metal. 2, we expect to get carbon dioxide gas. And 3, we expect to get water. Let's have a look at this example equation. That is action of carbonates, action of acids with carbonates. we expect to have three products when a dilute acid reacts with a carbonate. Three products are obtained when a dilute acid reacts with a carbonate. When a dilute acid reacts with a carbonate, take for example, when sodium carbonate reacts with dilute hydrochloric acid, when 2 moles of sodium carbonate reacts with dilute hydrochloric acid, we shall have dilute hydrochloric acid. When reacting with sodium carbonate, we shall have sodium chloride. We shall have sodium chloride, 2 moles in aqueous state, plus 1 mole of carbon dioxide gas, and plus 1 mole of water. How about when iron carbonate reacts with dilute sulfuric acid? When iron carbonate reacts with dilute sulfuric acid, 1 mole of iron carbonate, when reacted with 1 mole of dilute sulfuric acid, we shall get 1 mole of iron 3-sulfate. We shall get 1 mole of iron 3-sulfate plus 1 mole of carbon dioxide and plus 1 mole of water in liquid state. How about when calcium carbonate reacts with dilute nitric acid? Let's have a look at this reaction. When copper carbonate reacts with dilute nitric acid, then we shall get copper nitrate. We shall get copper nitrate plus 1 mole of carbon dioxide gas and 1 mole of water in a liquid state. Let's look at the test for the carbonate radical. How do we test for a carbonate radical in a laboratory? And how do we confirm that such and such a carbonate, and how do we confirm that such and such a material or substance is a carbonate radical?